Guys, welcome back to Maths with Arjun channel. In the previous video we have covered chapter 2 of the class 8th NCERT Maths, and today we are going to begin with the third chapter, that is understanding quadrilaterals. So without wasting any time, let's jump into the video. So the concept says that paper is a model for a plane surface. Now, except paper, it can be the floor, it can be the wall, but the condition should be that it should not have any ups and downs. So that thing or that model is called as a plane surface. And paper is one of the most suited examples, so we have considered paper as a model for a plane surface. Now moving on to what is a plane curve. Now let's see the definition. When you join a number of points without lifting a pencil from the paper. Let's draw one of the plane curve, like I am drawing it. So I am not lifting the pencil. So this is a plane curve. This is circle, but this is a plane curve. Let me draw one more plane curve without lifting the pencil. So this is a plane curve. Square or any quadrilateral. This is a plane curve. Let's draw one more figure. This is also a plane curve. And in bracket there is one more condition, and without retracing any portion of the drawing other than the single points. Without retracing. This means that there should not be overlap other than just the single points through which we are going to make the drawing. There should not be any overlap of between the lines of drawing, so that whatever we get, that is a plane curve. So let me draw one diagram and see if it's a plane curve. Now I have not lifted the pencil. First condition satisfied, but there is a retracing portion, that is it is cutting this line segment at 2 points, that is this point, this, and point this. So this is not a plane curve. Moving on to further concept. Now moving on to concept which we have studied, we are going to apply and do some sort of match the following to see how much we have understood. So first point says we have to find the simple closed curve. So seeing the first figure, we can clearly see that it is not a closed curve, so it is not a closed curve. So it is not a simple closed curve. Second figure is not a simple curve. It is closed but not a simple curve because there is some sort of crossing and overlapping of points. Now third is a simple closed curve, as we are not able to find the initial as well as the final point. So third point is a simple closed curve. Now we have found a closed curve that is not simple. First of all, we have to find a closed curve. First figure is not a closed curve. Second figure is not a simple. Third figure is already done. So the fourth figure is a simple, a closed curve that is not simple. Moving on to next point, simple curve that is not closed. Now we have to find a simple curve that is not closed. So first figure is that it is a simple curve but it is not closed. It's a simple curve because there is no retracing or cutting of the lines. Now moving on to fourth point, not a simple curve. So we left out is the second one, that is not a simple curve, as there is cutting off points in the center. So it's not a simple curve. Moving on to further. Now we have seen what's a closed curve, what's a simple curve, what's a simple closed curve. Now we have to see what is a polygon. So what's a polygon? So first condition is it should be a simple closed curve. That is, the initial as well as the final point should not be accessible, or we should not be able to cater which is the initial and the final point. Second thing is it should be a curve. That is, there should not be lifting of pencil while drawing the curve, and there should not be a retracing of point. And third condition is it should be closed. So we are not able to find the initial and final points, and it should be a closed figure. And another condition is it should only be made of line segments. That is, it should be used making only the use of lines and not any sort of curve. Now we can see, using the help of the diagram, the curves that are polygons. We can see in all these three curves, all the conditions that I have stated above get satisfied. That is, they are simple, the initial and final point is not visible, all three are closed, all three are curved, that is, there is no retracing or lifting of pen while drawing these, and all these three are made up of line segments. That's why these three are polygons. And the other three figures, the curves that are not polygons, are these three. These three are curves because we have not lifted the pencil while drawing these, but there is some sort of retracing. So first of all, some of them are not closed curves, and though they are made up of line segments, they are not satisfying all the conditions that I have mentioned, so they are not polygons. Moving on to further. Now there is classification of polygons based upon the number of sides. Based upon number of sides, the polygons can be classified and their naming convention is given. So the minimum number of sides or the vertices a polygon have is 3, and we call it, you already know it, as a triangle. Now whereas if we have the number of sides or vertices as 4, then it is known as quadrilateral. A 4-sided figure is known as quadrilateral. Now next is 5-sided figure. So 5-sided figure is known as pentagon. Similarly, 6-sided figure is known as hexagon. 7-sided figure is known as heptagon. 8-sided figure is known as octagon. Similarly, 9-sided figure is known as nonagon, and 10-sided figure is known as decagon. And similarly, going up to the n number of sides, where n can be any number, is known as n-gon. So this is the classification of polygons. Moving further. Now next concept is known as diagonals. Now what are diagonals? A diagonal is a line segment. First of all, it's a line segment. That is, it is made up of line connecting two non-consecutive vertices of a polygon. Two non-consecutive vertices of a polygon. Now what is a consecutive? Consecutive means side by side. That is the direct neighborhood. For example, in the diagram, the rectangle PQRS, what is consecutive vertices? P and Q are consecutive vertices. P and S are consecutive vertices. What are the consecutive vertices of Q? R and P are the consecutive vertices. So other than the consecutive vertices, that is non-consecutive vertices, if we join these 2 points, that is in the rectangle figure, PR and QS are the diagonals. And diagonals can be inside the figure as well as outside the figure depending upon the shape of the polygon. For example, in the third figure, that is KLMN, you can see that KM is the internal diagonal whereas LM is the external diagonal of the figure. Now moving further. So we have already studied what is a polygon. Now it's time for the types of the polygons. So there are 2 types of polygons, main 2 types of polygons, that is convex polygon and concave polygon. Now what are convex polygon? Convex polygons have all the diagonals within the shape of the polygon. That is, no diagonal outside the polygon is there, then the polygon is convex polygon. Now what is concave polygon? Concave polygon can have one or more diagonals outside the shape of the polygon. Now if this is the condition, then it is a concave polygon. Now you can see from the figure the convex and concave polygons. I have drawn the diagonals of the parallelogram that are inside the shape of the polygon. Also in case of rectangle, the shape of the diagonals is inside the shape of the polygon. Also in case of trapezium, the diagonals are within the shape. Similarly is with the hexagon, all the diagonals, and similarly with the octagon and further, all the diagonals are within the shape of a polygon. Now moving on to concave polygons, you can see that at least one of the diagonals is outside of the shape of the polygon. So it's a concave polygon. Now moving further. Now there are other types of polygons, that is regular and irregular polygons also. Now what is regular polygon? Regular polygon has 2 conditions, that is all sides as well as all angles should be of equal length. And what is the case with the irregular polygon? That is not having all sides and not having all angles as equal, which means there can be one pair of side equal and other not equal to, or opposite sides as equal but not all angles. That is, opposite angles can be equal but other pair of opposite angles or adjacent angles may not be equal. In that case, it's an irregular polygon. You can clearly see from the figure, that is in case of regular polygon, we have shown the figure of the regular pentagon as well as regular hexagon. Similarly, in case of polygons that are not regular, that is irregular, only one pair of sides are equal whereas the adjacent sides are not equal. So it's a case of irregular polygon. Similarly, in the second figure of the irregular polygon, the adjacent sides are not equal. In some case it's equal but some case it's not equal, whereas all the sides and all angles should be equal, then only it's the case of regular polygon. Now moving on to further concept. Further concept says the angle sum property. Now we have already studied in the previous class and previous to previous class that the inside angles of the triangle, sum of all angles of inside the triangle is equal to 180 degree. So you can see in the figure of the triangle shown, that is angle 1 plus angle 2 plus angle 3 is equal to 180 degree in case of triangle. This is only known as angle sum property of a triangle. Now let's see how this property helps us in solving the angle sum property of a quadrilateral. So first of all, let's see the figure that is given as ABCD, and we have drawn the angles and divided the figure by using the diagonal AC. So this has divided the figure into two halves, each being a triangle. Now here we are going to use the angle sum property of triangle, which I have stated before. So from using that property, you can see in the figure that angle 1 plus angle 3 plus angle 2 comes out to be equal to 180 degree from the angle sum property of a triangle. Similarly, angle 4 plus angle 6 plus angle 5 comes out to be equal to 180 degree. Same using the angle sum property. Now adding these both equations, we get angle 1 plus angle 4 plus angle 2 plus angle 5 plus angle 3 plus angle 6 comes out to be equal to 360 degree. So you can clearly see from figure that angle 1 plus angle 4 is nothing but angle A. Angle 2 plus angle 5 is nothing but angle C. Angle 3 is nothing angle D, but also angle 6 is nothing but angle B. So angle B plus angle C plus angle D plus angle B again comes out to be equal to 360 degree. So this comes out to be the angle sum property of any sort of quadrilateral. Now moving further, so we have to see the general angle sum property. So the general angle sum property is nothing but n minus 2 multiplied by 180 degree, where n is the number of sides of a polygon. Now coming to the first question of exercise, that is exercise 3.1 of this chapter. Now the question says, given here are some figures and we have to classify each of them on the basis of whether it's a simple curve, it's a simple closed curve, it's a polygon, it's a convex polygon, or it's a concave polygon, or some of them or all of them. We have to find. So on seeing the first figure, we can say that it's a simple curve. Why? Because we can draw it without lifting the pencil, and there is no cross or cutting or retracing while drawing this figure. Also, it's a simple closed figure. Now it's a simple curve and it's a simple closed figure, and also it's made up of only line segments, so it's a polygon also. Moreover, that there is a external diagonal, so it's a example of a concave polygon. Now moving on to the second figure, we can say it's a simple curve because it's made up of without lifting the pencil, and there is no trace of retracing or overlapping of any line. So it's a simple curve. Also it's closed, so it's simple closed curve. It's made up of only line segments, so it's a polygon, and all the diagonals are within the figure, so it's a convex polygon. Now moving on to the third figure. Now we can clearly see that the third figure cannot be made without lifting the pencil, either if we are making the internal circle or the external circle first, we have to lift the pencil. So it's not a simple curve. So if it's not a simple curve, we don't have left with any other option. So the option says that it does not satisfy any of the conditions. So there is none of the option which satisfies the third figure. Moving on to fourth figure. Making the fourth figure, we can clearly see that though we can make it without lifting the pencil, but there is crisscross and retracing of lines here, here and here. So it's not a simple curve. So similarly in the previous example as also there is not simple curve. So there is no option of simple closed curve, polygon, convex or concave polygon also. So it's none of the condition is satisfied. Now moving on to fifth figure, we can clearly draw it without lifting the pencil, and also there is no retracing of points and line segments. So it's a simple curve. Also it's a simple closed curve, but it's not a polygon because it is not made up of line segments, but it's made up of curves. So it's not a polygon. So there is no further viewing on whether it's a convex polygon or concave polygon because it's not a polygon. Now moving on to figure number 6, we can see that it's a simple curve. Conditions I have already discussed in many of the examples. Also it's a simple closed curve, but it's not a polygon because there are curves also, though there are line segments, but there are curves also. So it's not a polygon, and also it's not a polygon, then there is no further viewing whether it's a convex or a concave polygon. Now moving on to figure number 7. Now figure number 7 is a simple curve. Condition I have already discussed what is a simple curve. It's also a simple closed curve, but there is a curve, so it's not a polygon. And if it's not a polygon, there is no condition to see whether it's a convex polygon or a concave polygon, because it's not even a polygon. Now moving further, moving on to figure number 8, we can see that also we would have to lift the pencil to draw this, and also there is retracing. So it's not a simple curve. If it's not a simple curve, also it's not a simple closed curve, also it would not be a polygon, and if it's not a polygon, there is no case whether it's a convex polygon or a concave polygon. Now moving further to next question, that is question number 2. So it says, how many diagonals does each of the following have? So I have to find the number of diagonals a convex quadrilateral have. So what's a convex quadrilateral? A quadrilateral having all the diagonals within the shape of the quadrilateral. So we can clearly see that there are 2 diagonals in case of convex quadrilateral. Similarly, in case of a regular hexagon is a hexagon having all the angles as well as all the sides being equal. So on drawing it, you will find and counting that the number of diagonals comes out to be equal to 9. Now moving further, next is in case of a triangle. So a triangle does not have a diagonal, or it has 0 diagonals. Now moving further to next question. Now next question says, what is the sum of the measures of angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex, that is concave? So first of all, we will see what is the sum of the measures of angles of a convex quadrilateral, and then we will see in case of concave quadrilaterals. So from the figure ABCD, you can clearly see that it's a convex quadrilateral because it is not having any of the diagonals outside the shape of the quadrilateral, and AC is the diagonal. On drawing AC diagonals, we get angle 1, 6, 3, 4 and angle 2 and angle 5, B and D respectively. Now here we are going to use the same property which we have used for solving the angle sum property of a simple quadrilateral, which was also a convex quadrilateral. And we are going to use the angle sum property of the triangles, as diagonal AC has divided triangle ACB and triangle ADC respectively into two triangles. So using the angle sum property, we will get angle 1 plus angle 2 plus angle 3 equal to 180 degree. That is angle sum property of a triangle. Also angle 6 plus angle 5 plus angle 4 equal to 180 degree. That is angle sum property of a triangle. On adding these two equations, we get angle 1 plus angle 6 plus angle 3 plus angle 4 plus angle 2 plus angle 5 equal to 180 plus 180 equal to 360 degree. Angle 1 plus angle 6 is nothing but angle A. Angle 3 plus angle 4 is nothing but angle C. Angle 2 plus angle 5 is angle B plus angle D respectively, which comes out to be equal to 360 degree. We have to find the sum of the measure of angles of a convex quadrilateral, so it comes out to be 360 degree. Now let's take the case of a non-convex quadrilateral, that is concave quadrilateral. You can see from the diagram that if we draw diagonal AD, it's the diagonal outside the shape, so it's a concave quadrilateral. Similarly, we are going to draw diagonal BC, which will divide triangle ABC and triangle BCD into two halves. That is, quadrilateral get divided into two triangles, and we are going to solve it using the same properties as we have solved using the in case of convex quadrilateral. So here we can clearly see angle 1 plus angle 2 plus angle 3 comes out to be equal to 180 degree, angle sum property of a triangle. Similarly, angle 4 plus angle 5 plus angle 6 would be equal to 180 degree. On adding these two equations, we get angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 equal to 180 degree plus 180 degree equal to 360 degree. So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 is nothing but angle A plus angle B plus angle C plus angle D, which again comes out to be 360 degree. So we can clearly see that if it's any sort of whether a concave or convex quadrilateral, the angle sum property holds true, and it's always sum of the interior angles of quadrilateral is equal to 360 degree. Now moving on to question number 5. It says, state the name of a regular polygon if it has 3 sides. So we know it's an equilateral triangle. If it has 4 sides, then we call it as square, and if it has 6 sides, then we call it as regular hexagon. Now moving on to next question, that is question number 6 of exercise 3.1. We have to find the value of angle x in each of the figure. So we can see from the figure that angle x is also the interior angle, and the sum of the interior angles of any quadrilateral is nothing but 360 degree. How we know? It's the angle sum property of the quadrilateral. So x plus 50 degree plus 130 degree plus 120 degree comes out to be equal to 360 degree. X plus 300 degree comes out to be equal to 360 degree, and finally the value of x comes out to be equal to 60 degree. Now let's see the another figure, figure 2. we can clearly see that the outside given angle is equal to 90 degree. So the inside angle would also be equal to 90 degree. Why? Because a single straight line forms 180 degree angle. That this is you have to remember. So the internal angle would also be equal to 90 degree. And also we know that the sum of the interior angles of a quadrilateral is equal to 360 degree. So using that property, x plus 90 degree plus 70 degree plus 60 degree comes out to be equal to 360 degree, and x plus 220 degree comes out to be equal to 360 degree, and finally the value of x comes out to be equal to 140 degree. Now moving on to the another figure, we can clearly see that the value of two angles is x and the x and x, so angles would be equal to each other, and using the same property that I have told, that is angles on the single line straight line comes out to be equal to 180 degree. So outer angle is 70 degree and inner angle would be equal to 110 degree, and also outer angle is given as 60 degree, so inner angle would be equal to 120 degree. And using the angle sum property of, this is not a quadrilateral, so we are going to use the property of n minus 2 into 180 degree, where n is the number of sides of the polygon. So it's a pentagon, so n minus 2, that is 5 minus 2, 3 into 180 degree, which comes out to be equal to 540 degree. So here the sum of the angles interior of a pentagon would be equal to 540 degree. Using that property, we get 30 degree plus 110 degree plus 120 degree plus x, that is 2x, is equal to 540 degree. 260 degree plus 2x comes out to be equal to 540 degree, and 2x comes out to be equal to 280 degree, and x comes out to be equal to 140 degree. Now moving on to the last part of question number 6 and last question of this video. Now we can clearly see from the figure that the sides are given as x, that is sides are equal, so angles would also be equal. So it's a regular pentagon, and we have already seen that in case of a pentagon in the previous figure, the sum of the angles comes out to be interior angles of a pentagon is equal to, using the formula n minus 2 into 180 degree and putting the value of n equal to 5, we get as 540 degree. So 5 times x equal to 540 degree, and finally the value of x comes out to be equal to 108 degree. So we will keep the questions and the concept of this video till here, and we will solve the next question, that is question number 7 that is the last question of this exercise, in the next video. So if you like, kindly like, share and subscribe the video as well as the channel, and thank you so much.